And then tomorrow we're going to do...
Good afternoon, everyone. Thank you for joining us.
We
are recording. Welcome back, and we're glad that you're here. I'm Steve.
And I'm Scott.
And together we're Backyard Musing Science and Technology Channel.
Yep, just showing my gang affiliation there. Yep, and we're talking about another science topic involving space, which we like to talk about space. So
yeah, this was interesting. Scientists propose that life-sustaining environments may exist on moons orbiting free-floating planets drifting through interstellar space. These free-floating planets, they're called rogue planets, different than exoplanets. Exoplanets are planets not in our solar system that rotate about a star, their own sun. So this is just kind of happily going throughout. It might get caught in the gravitate, might affect its path by a star, but it hasn't been captured by a star yet. Liquid water is widely seen as a key ingredient for life. New research suggests that stable, life-supporting environments may also exist from any star. A team from the Excellence Cluster Origins at LMU and the Max Planck Institute for Extraterrestrial Physics, MPE, found that moons orbiting free-floating planets can keep their oceans liquid for up to 4.3 billion years. Not sure how they found that out.
Well, they're getting their money's worth. That's for sure.
Okay, yeah, they're getting money. Give me your money. Dense hydrogen atmospheres combined with tidal heating could sustain these conditions for nearly as long as Earth has existed, long enough for complex life to emerge. Would you like to know more?
Here we go. Planetary systems often develop in chaotic ways. When young planets pass too close to each other, gravitational interactions can eject from them from their systems. These objects become free-floating planets, or FFPs, drifting through the galaxy without a host star. Earlier work by LMU physicist Dr. Giulia Rossetti showed that gas giants expelled in this way can still retain some of their moons.
Like Jupiter is a gas giant. Okay. After ejection, the orbits of these moons change significantly. They tend to become highly elongated, causing their distance from the planet to vary constantly.
This leads to strong tidal forces that repeatedly flex the moon, compressing its interior and generating heat through friction. This internal heating can be enough to maintain liquid water oceans, even in the extreme cold of interstellar space and without any starlight. Wow, that's out there.
Yeah, so something popped into my head. I'll say it. Like on Star Wars, Yavin was a planet, and the rebels were on one of the moons of Yavin, Endor. That was a moon, and it was habitable. Okay, just thought I'd throw that in there. Okay. Whether that heat remains at the surface depends on the atmosphere. On Earth, carbon dioxide acts as a greenhouse gas. Previous studies suggested it could support habitable conditions on exomoons for up to 1.6 billion years. However, in the frigid environments around free-floating planets, carbon dioxide would freeze and lose its ability to trap heat.
To address this, researchers from astrophysics, biophysics, and astrochemistry explored hydrogen-rich atmospheres. Although molecular hydrogen does not usually absorb infrared radiation well, it behaves differently under high pressure. Okay.
A process called collision-induced absorption allows colliding hydrogen molecules to temporarily form structures that can absorb and retain heat. Unlike carbon dioxide, hydrogen remains stable at very low temperatures, making it an effective insulating layer in these conditions.
Study also offers insight into how life might begin. Quote, our collaboration with the team of Professor Dieter Braun helped us recognize that the cradle of life does not necessarily require a sun. That's according to David Dahlbuding, doctoral researcher at LMU and lead author of the study. Going on with the quote, we discovered a clear connection between these distant moons and the early Earth, where high concentrations of hydrogen through asteroid impacts could have created the conditions for life, unquote.
Tidal forces may do more than provide heat. The repeated stretching and squeezing of a moon can create wet-dry cycles where water evaporates and then condenses again. These cycles are thought to play a key role in forming complex molecules and may support critical steps toward the origin of life.
Free-floating planets could be widespread across the Milky Way. Some estimates suggest that they may be as numerous as stars. Their moons, if present, could offer stable environments for billions of years. These findings expand the range of places where life might exist and suggest that living systems could arise and persist even in the darkest parts of the galaxy. Ooh, that's interesting.
I think it would be extremely difficult to find one of these because we normally zero in on a star and then look for planets that go across the star, you know? If it doesn't have a star, this would be like a needle in a haystack out in space trying to track one.
Yeah, and how do they know if their environments are habitable, being that far out? I mean,
it's computer simulations. They're taking the computer with the physics that they know and trying to see, it's all modeling.
It's possible, like a ghost planet, right, or a ghost town planet, a planet that may have been
Calico.
What's that?
Calico.
Calico. Yeah, that would be a great name for a
ghost town
planet or a star or ghost planet. Calico. Yeah. He's referring, for those of you that don't live in Southern California, he's referring to an old ghost town. Used to be an actual ghost town, a mining town that was taken over by the Knotts family many years ago, and now it's kind of a Calico ghost town theme park, if you want to call it, but not theme park like you think about Knott's or Magic Mountain or Disneyland. So just saying. But anyway. Okay.
All right, folks. There you have it. We hope you enjoyed this segment.
Yep. We love talking about space. So, okay. We'll see you on the next one. Take care. Thanks.